When we think of black holes, we often picture them as the remnants of collapsed stars or the giants lurking at the centers of galaxies. Massive, ancient, born in the aftermath of violent explosions or the steady swallowing of cosmic matter. But what if some black holes are older than stars? What if they were born not from death, but from birth? Welcome to one of the most intriguing possibilities in modern cosmology: primordial black holes. These black holes, if they exist, would have formed in the very earliest moments of the universe, within the first second after the Big Bang. Not from collapsing stars, but from intense fluctuations in density. Regions where matter piled up just enough to collapse under its own gravity, even before atoms or light had time to form. They are, in theory, relics from a time before time as we know it. Let's imagine it. A universe just born, not yet a minute old. Temperature, billions of degrees. Pressure, unimaginable. Matter and energy rushing outward in every direction, chaotic and hot, but not perfectly smooth. Tiny quantum fluctuations, the seeds of galaxies to come, rippled through the early universe. In some spots, these fluctuations were so dense, so compact, that they collapsed into black holes on the spot. These are the primordial black holes. Unlike their stellar cousins, they could have come in any size, from microscopic to millions of solar masses. Their mass spectrum could be wide, varied, and full of surprises. Some might have evaporated quickly via Hawking radiation. Others might still be drifting through space today, invisible, ancient, undetected. And here's where things get even more fascinating. Some scientists speculate that primordial black holes could be a component of dark matter, the invisible substance that makes up about 27% of the universe. We don't know what dark matter is. We've never seen it directly. But we've mapped its effects. It holds galaxies together. It shapes cosmic structure. And primordial black holes, if they exist in the right numbers and sizes, could explain some of those effects. Could the dark scaffolding of the cosmos be built on ancient black holes? It's a bold idea, and it's still debated. But recent observations have reignited interest. In 2019, the LIGO and Virgo detectors observed several black hole mergers with strange characteristics. Black holes heavier than expected, and more common than predicted by stellar evolution models. Could these be primordial? Maybe. It's too early to say. But the pattern is curious, and the possibility that we are hearing the death cries of black holes older than galaxies is breathtaking. Primordial black holes also offer potential answers to other mysteries, like the supermassive black holes we see at the centers of galaxies. Some of them formed so early in the universe's history, it's hard to explain how they grew so big, so fast. But what if they didn't grow? What if they started that way? A primordial black hole, born with 1 million solar masses, could act as a seed, drawing in matter, forming stars and galaxies around it, rather than the other way around. In this view, black holes didn't just emerge from galaxies. Galaxies emerged from black holes. It's a reversal, a reimagining. And while it's still theoretical, new telescopes, like the James Webb Space Telescope, are pushing further into the early universe, looking for the light of the first galaxies, the first stars, and perhaps the gravitational shadows of something even older. Primordial black holes might also leave behind signatures in the cosmic microwave background, the afterglow of the Big Bang, tiny distortions, lensing effects, anomalies in the smoothness of that ancient light. We're searching, we're listening, because if we could find even one confirmed primordial black hole, it would change everything. It would give us a glimpse into the first second of the universe, a time we can barely model, let alone understand. It would be like finding a fossil from before the Earth cooled, a message in gravity from a time before time. And yet, in some ways, these black holes may be closer than we think. They could be drifting through our galaxy right now, passing through solar systems, maybe even through our own solar system. Silent, dark, undetected, not dangerous unless we happen to be in their direct path, but present, real, ancient passengers in the sea of stars. They challenge our assumptions that all black holes are born from stars, that galaxies came first, that darkness follows light, because perhaps in the beginning there was darkness, and from that darkness everything else emerged. Primordial black holes remind us that the universe still holds secrets it has never revealed, that not everything bright is important, and that sometimes the oldest things leave no light at all, only gravity, silence, and mystery. Tonight, let that mystery wrap around you like the night sky. Imagine a black hole older than time, drifting, waiting, whispering. And remember, in every direction you look, there may be something out there, older than light, still pulling on the fabric of reality, waiting to be found.